Hello, welcome to the Dev Method. My name is Ricky. Today we're talking about one of the last chapters of 100 exercises to learn Rust. So there's this repo I found, and it's like interactive. So you're going to go ahead and complete 100 different exercises in Rust where you're filling in implementations, like you're filling in the implementation of a function. Maybe you're changing some of the signatures, like the return type or the parameters. You're filling in structs. Essentially, what you're doing is you're learning Rust in a more interactive way instead of using just a video and hearing about it. So it forces you to just try and take control and learn more in Rust. So that's what we're doing today. And that's what we've been doing the past couple of streams, if you want to go back and watch any of those. But yeah, so let me show you more or less what it is we're working on today. And so here we go. So here's the repo. The link's in the description. And from here, on the main branch, you go to exercises. And within there, you have a bunch of different like chapters. So all these right here would be like the chapter. So we've done intro, basic calculator, tickets v1, traits, tickets v2, ticket management. We just did threads. We finished that up, and we started yesterday actually, futures. So async programming. So that's what we're going to continue doing today. And let's see, we did the spawn. I think we're on runtime now, or maybe, yeah, well, I don't know. We're somewhere right at the beginning. But then, yeah, we're going to keep going to the end, see how far we can get today. Yeah, so that's that. One thing to keep in mind if you're going to do this on your own, if you scroll down a little bit in the README, they do talk about a solutions branch. So there's a branch you can go to just look up the solutions if you want. There's also a more of like a guide, so it explains a little bit more of what you're trying to learn in each of these exercises. So for example, this is rust-exercises.com/100-exercises. And when you go here, you have this breakdown of all of the different exercises that you're doing. I'm going to go down to the bottom and just show you. Sometimes it's really small, there's not much there, and you're meant to go like look up stuff online or look at the libraries. But yeah, so here's like spawning a task. So we can see what that looks like here, and we can read through it. So I think this is where we left off, so we'll just leave that there for now. Yeah, so let's take a moment to get set up. I want to make sure it looks good for you guys. Cool. And let's see, how's that look? Maybe make it a little bit bigger. Okay. Yeah, so here we go. Okay, so I think we're ready to go. Let's go to the exercises. Let's do our futures. All right, so let's just review what we did before. Now, when you get into these exercises, these are all isolated Rust packages. So you can go ahead and just cargo run on any particular package. So like, for example, I'm in the async fn folder. This exercise has a source directory and a cargo.toml. So if I do cargo b to build, you'll see that it looks like I've already built this, so it didn't take too long. But it would install any dependencies that are in the cargo file, toml file, and then also compile the code. Sometimes you run the code. So like cargo run or cargo r, and it's going to run as if it had a main function. And then there's cargo test, so you can run your tests. I don't see any integration tests, but sometimes there are. You'll see that alongside the source directory. So right now, I'm guessing if we had tests, they would be in the source directory, not beside the source or a sibling to the source directory. So let's take a look here. And then you look at your to-dos. So I have a to-do here, and I don't have any other to-dos written. Sometimes there is the macro to-do, and you're supposed to replace those with an actual implementation. So that's something you could do too. But yeah, it looks like we already did this particular exercise. I can see that because my changes here, I have a little line on the left-hand side to see that. So yeah, let's maybe just do a little review of what we did, and then that'll be like our warm-up to get started for the rest of the code that's there. So let's see. All right, I'm gonna make it just one step bigger. Yeah, maybe like that. Okay. So we had this test, and everything was already implemented in the test for us. So the next thing that we had to do was fill in this implementation. So let me go to that here. And essentially we're building an echo server, it said, and we're using Tokio to do this. So Tokio, the dependency, has brought in this async runtime for us. It's probably, I think it was listed in the content of the book, just giving you examples of not just Tokio, but others. But essentially, it allows us to write our async part here and work with functions that also await or suspend. So that's what's happening. So we have this listener, which gets a stream. We split the stream so that we get the writer and the reader, and then we flip them. We copy one into the other, and that looks like it's our echo server. Also, we did, it looks like anyhow is the crate we're using for errors. Yeah, so that's just what was in the project, but I didn't have to write that part, but I pointed out because there's this question mark. So what if this asynchronous function fails? It'll propagate that up here in result. So that is a common Rust thing, not just for asynchronous programming, but also for here as well. So you can propagate an error from an await or an async function. So yeah, let's just double check that it runs. So cargo test. Okay, everything worked. And then we move on. So that's what we're going to do. Okay, so looks like we just did the first thing. Then let's do spawn. Let's see what we got there. All right. Yeah. Okay, so write an echo server that accepts a TCP accepts TCP connections on 2 listeners concurrently. Okay. So multiple connections on the same listener should be processed concurrently. The received data should be echoed back to the client. Interesting. Okay. So listening on 2 servers, but sending back. So multiple connections should be processed concurrently. Okay. I think we probably have to do some sort of like joining or something like that. So it's very similar to the concurrency in threads that we had before, but I'm not really sure how to do this. I haven't done a lot of async programming here before. So what I usually do is then read the test and just see what I could come up with. All right, so we have this bind random. So looks like random connection, random port. Okay, get the address, return that with the listener. Okay. Okay, here's the spawn part. So Tokio spawn. So I suppose that's what we're supposed to do too. And here's a couple of requests that they're going to send through. And for each one of the requests, which basically are just sending a word, So hello world foo bar. For each one of the requests, we will, okay, so we have the first and the second address that we're sending to, so the two listeners. Okay, join set spawn. Where did this come from? Oh, okay, so new join set. All right, spawn, and then we have open up the connection, split, kind of like what we did before, write the contents of the request, so all the bytes from those strings, await, unwrap, shut down. Okay. And let's see, we have a buffer, read to the end of the buffer, and see if the buffer was the same as the request. Hence, that is the echo server, sending back what it received. Okay, so that's what the test does, and we need to fill in the implementation for this. So I'm actually not sure. So we could go look up Tokyo and learn how that works. And so I'm going to skip that part of it and look up the information here. Okay, so the previous exercise should look something like this. Yep, that's what we did. This is not bad. It's a long time pass incoming connections, echo function, thus allowing the executor to run other tasks in the meantime. Okay. But how can we have multiple tasks running concurrently? If we always run our synchronous function until completion using await, we'll never have more than one task running at a time. Yeah, that makes sense to me. So if you have multiple things coming and they're always waiting on that same function, everybody's always waiting. But you want to do multiple at the same time, so they're saying Tokyo spawn is what comes into play here. Okay, so Tokyo spawn allows you to hand off a task to the executor without waiting for it to complete. Okay, cool. So when you invoke Tokyo spawn, you're telling Tokyo to continue running the spawn tasks in the background concurrently with the task that spawned it. Here's how you can use it to process multiple connections concurrently. Okay. So yeah, that's our thing, our function. So we're gonna do a loop again. Here's where we accept something that's there, and they're saying this is the socket, which I think actually that's the string. I think this is a error in their documentation, or maybe, I don't know, something, the Tokyo version changed or something. I'm pretty sure the stream is first. Let's get that here, just to double check. I'll say X for now and Y. And that was first dot listen. Oh, dot accept. First dot accept. Unwrap. Oh, wait. Let's do that. So okay. Yeah, the stream is the first thing, not the socket. So the stream is the thing you split on. Okay, so different than last time is this part. So spawning the background task with Tokyo spawn. This is also an async function so that you can use the await in here. And we do need to move ownership into this spawn thread. So that's what this is doing here. All right, so we ignore this part, I guess. And we just do this. This is the stream. Stream. Okay, and then we do spawn. and they said async move. Cool. And then no arguments to that. Does it return anything? Nope. All right, so from in here, we get the reader writer. And that would be stream split. Yeah. And then they said, oh yeah. And then you flip them around. Okay, so Tokyo IO copy, just the regular copy. Okay. Borrowed mute to the writer. Then whoop, forgot the T. And borrowed mute to the reader. And that should be that. Yeah. Oh wait, reader, writer. Oh, because these are not mute. Okay. All right. There we go. Oh, we got a warning. Let's see what the warning says. Oh, unused future. Okay. That's fine. But let's keep reading here. So writing it out helped me there understand that it is the stream, not the socket, that we split. Okay. So asynchronous blocks. In this example, we've passed an asynchronous block to Tokyo spawn. Asynchronous blocks are a quick way to mark a region of code as asynchronous without having to define a separate async function. Yeah, so it's kind of like an anonymous function, is what that's saying. Okay, but then we need to join. Yes, that makes sense. All right, so returns a join. That's what this does. A join handle. There it is. So it's a future. And I guess we would have to await it. If we await it, what do we get? We get a result. Okay. So Tokyo spawn. Oh, sorry. Hold on. Tokyo spawn returns the handle. There's our join handle. Yeah. Okay. So, well, we didn't put the await there ourselves. So let's do that real quick. Await like that. Okay. But this is saying we can't do that. Oh, interesting. All right, it's saying we can't propagate the error in the spawn. All right, we'll get back to that. So yeah, spawn, get the handle, and then use the handle to await. So yeah, do some other work and then await the handle for emit telemetry or whatever your function ends up being. In the same way we used join for threads, okay? Yeah, so there's some other work that needs to be done. It doesn't have to be done in order. That's what that's saying there. So you can get this going, and then it says turn the route server. In the meantime, do some other useful work, but don't return to the caller until the telemetry data has successfully delivered. So that's what that's saying there. Or just, that function has completed its work. Okay, so panic boundary. If a task, let's see, so if a task spawned with Tokyo spawn panics, the panic will be caught by the executor, okay? If you don't await the corresponding join handle, the panic won't be propagated to the spawn. Okay. Even if you do .await the handle, the panic won't be propagated automatically. awaiting a join handle returns a result. Yes. With join error as a type, then you can check if the task panicked by calling error.isPanic. Oh, okay. And choose what to do if the panic is there. Okay. So what they're saying is, here's our spawn where we do some work. We await. If there ends up being an error, then we execute this block of code here. And then let's see, it's trying to see if it's a panic with a reason. And it's saying, okay, if you have a panic, then this is the reason, and you can do whatever you want with that. So the task is panicked. We resume unwinding the panic, thus propagating it to the current task. Okay. So this here is propagating it to whatever task we're currently running from the beginning here, it looks like. So, all right, we're getting close to the end here. So you can think of spawn as an asynchronous sibling of thread spawn. Yep, that's what I've been thinking so far. Notice a key difference with thread spawn, you're delegating control to the OS scheduler. Okay. You're not in control of how threads are scheduled, correct? With spawn, you're delegating, or with Tokyo spawn, you're delegating to an async executor that runs entirely in user space, meaning like in our application or in our program. So the underlying OS scheduler is not involved in the decision of which task to run next. We're in charge of the decision now via the executor we chose to use, which in this case would be, I guess, Tokyo, unless Tokyo has some other configuration, but yeah, okay. So going back to the exercise, we would want to, I guess, return a result. So I guess we would do handle dot await, like so. Oh, but yeah, we got to figure out this part. Okay, that was in their example, but it looks like you can't await. Okay. So what would this have returned? This would have returned something. And then the join handle. Yeah. Trying to learn the types here so that I could do first and second. So I guess I could do one and the other, I think is the idea. Okay. Let's see. What does this return? A result of a result. Okay. So maybe it's unwrap just for now. And then we have a result with an error. Okay. So we don't need the type here. So I guess if we did that, that would get rid of it. Yep, so we're not returning anything. I know it's weird, the implicit return, right? So we were returning something before, and that would have caused an error down here because it doesn't match with the signature of this function. But we'll take that out. We keep the semicolon at the end, and we go from there. So that's interesting though. So they had in their example the question mark for propagating the error. But let's take a look at the signature here. Let's see. Start running in the background immediately. Okay, cool. Spawning a task enables the task to execute concurrently with other tasks. Okay. Okay. Here's some examples. Yeah, see there's no propagating the error here. Right there. Let's keep going. All right, to run multiple tasks in parallel, which is what we're looking to do. And and receive their results. Join the handles can be stored in a vector. Okay, I see. Spawn this, push it to a vector, store this, push it to a vector. And then for each task in that vector, you await. Guess that's what they're saying. Panics if called from the outside. Okay. Oh, this is interesting. Use the exclamation point send values from a task. I don't know about that. I don't know if we're supposed to learn that quite yet. Just trying to look and see. Okay. So I think what I got from that was we could do we can have a some sort of group that is a vector of, well, I actually don't know if we could do, it's a vector of something. So let mute group. Okay, we don't know what it is quite yet, but we could say group.push the handle, call h1 for handle. So we do the h1 here, and we do the same thing, but for I'll call this h2. Take this out of there. We do this for h2, and then we could do something where like for tasks in group tasks.await, and then I guess we would just return OK at the end. Like so. Yeah, is that what we do? Let me go back to the documentation. Okay, Tokyo spawn. Let's keep going. Where's our handle? All right, so here's multiple handles being pushed onto a vector. Okay. And you take those tasks, loop through them, and then you await unwrap. Okay. So, don't know if that's exactly what they want us to do here. Let's see, what is this error? Oh, it wants a result. I thought I am returning a result. X equals the result. X. It's unknown error. That's why. Yeah, I'm not sure if this is what they would want. This is kind of the idea. Then I guess I would call this stream 1. Whoop. Stream 1. But then here we want stream 2. So let mute stream 2. Forget that part. And this would be the second dot accept, await, unwrap. Okay, string 2. That can all be the same. And we await for both of them here, I suppose. What, join? Oh, and then there was talk about a join set, which I saw in the test. Is that what we're also supposed to use here? That is something I'm not sure about. Let's see. So, all right, I think we're going to go to the solution branch and just take a look. Futures, spawn. All right, source directory. Okay. Oh, look at that. They broke it out into another function. Okay, so they have echo and then echoes. So what they did there was they listen and accept on the spawn here. First spawn for handle 1 and then handle 2. And then they do use Tokyo join. Oh, a macro. Okay. Guess there's a macro there we could use. Join 2 handles. Get the outcome 1, outcome 2, return if we're good. Okay. So, and then so we're looping in each of these spawns. All right, so that is something I wasn't quite catching. So here's what we got to do. Let's remove this, get rid of this idea of vectors. Okay, so we're pretty close. We are pretty close. So let's put this here. What I will do is just break this up here, like so. And this goes here. Okay, it's basically what they had. But now we wrap this in a Tokyo spawn. Okay, it's an async move. Okay, and we go here, take this, put it in there. Well, let's see, oops, auto formatting. There we go. All right, so let's do, oh, and then do they return this? I think they return this. So let's return that, like so. But then this part, yes, unwrap. Oh, but they don't return anything from here, and they don't return anything from here. Okay, so what we would do is do that. Okay, and I'm not sure why we do the unwrap here, but we will do it. And let's do that down here. Unwrap, and then we'll make it look closer to their implementation. So let's do this. All right, so that's basically what they have here. Tokyo spawn, async move, basically doing the same thing again, but for the second. Yeah. And at the end, let's just say okay. Satisfy compiler. I'm going to do a return okay because I feel like the implicit returns have gotten us a little bit in trouble. All right, so this is what they're doing for each one. And then they take the handle from here, let handle 1, okay? And then let handle 2, okay? And then they use this Tokyo join macro, okay, for H1 and H2. And what are they getting from that? They're getting some sort of result, okay? And what are they doing here? They're not awaiting it, they're unwrapping it? Oh, I don't know. Are they just returning it? What was their solution? Oh, okay. 2 outcomes from both joins. So it is a tuple. Okay. Outcome 1, outcome 2, because we defined there was H1 and H2. So we have outcome 1, outcome 2. And then they're saying outcome 1 is a result. But I'm curious what this first result is. So I'm not sure what this marker is here, actually. This bang operator. Well, it's not a bang operator, but it looks like it. That is what it is. And then they do something like that. That's what they do. That doesn't return anything. Is that what the idea is? Whoops. Did it again. Okay. Can only be applied to try. Oh, okay. So maybe the exclamation point is a try. Like that. Outcome 2. So maybe something's changed since they made this here. Okay, so we got Tokyo join, and then just say it's okay. So I could break it up into another function if I wanted to, which is basically what this is here. Again, they called this socket, but I know it's stream, because then this is a socket, so I don't know. Don't know why that's like that there. But let's keep going, because I think that is all we needed to do. So we basically needed to just do what we had before, but wrap it in a spawn. Do that twice because there's 2 of them. And because we know that there's 2 of them, there's this Tokyo join we can do from both of those handles, those join handles that came from Tokyo spawn. We use this macro here, which has a variable length that we're defining in our code. And therefore we get a variable length of a tuple. And we just do something. I guess we're just making sure that they're okay, both of those, with this, because if there was something wrong, it would propagate as the error here in the function signature. Otherwise, we're good to go. You return okay. So yeah. All right. So that's that. But then let's see if it passes the test. Cargo test. All right, passed. Okay, cool. So I'm just gonna leave it like this. Yeah, okay. So next one. Let's check our time here. Okay, cool. All right, if you haven't done so already, take a little break. When you're learning something, it's good to take breaks. I don't know what it is. There's probably some sort of psychology behind it, but it's like it's soaking in. Also, if your brain hurts from watching this, I apologize. I'm stumbling and fumbling through this, but also at the same time, might mean that you're learning something. You know, there's the visual learners, there's the auditory learners, and then the kinetic learners. So we're practicing all 3 today for me. You guys got to do this too, and you can get the kinetic learning, which is like hands-on, touching something like the keyboard and the mouse, hearing the clicks. That's your auditory maybe. It's all like associating together. All right, anyways, without talking more about learners. Let's go to the runtime. I'm excited for this one. I don't know what we're going to learn, but we're going to learn something. So we're going to keep going. All right, implement fixed reply function. It should accept 2 TCP listener instances. Accepts connections on both of them concurrently. Okay, Tokyo spawn, right? And always reply to clients by sending the display representation of the reply argument as a response. Okay. We're going to have to learn some new stuff here. So they're talking about display. We've used that before. And we're given 2 listeners, but the reply is of type T, where it has to be send and sync, and it has to exist for the entire duration of the program with this lifetime. And it also conforms to display, because we're going to call display on it. So just to show you here. Whoop. Reply dot display format. It's a format, yeah. So we could just pass it to a string in a string format, and it'll format for us. So that's what we're going to do. Let's keep looking. Let's look at the test. Okay, let's bind random, same as before. Okay, join set. Here they go. Join set spawn on 2 different things, 2 different sending of the message. Okay, they're double checking if the bytes sent are the bytes received. Okay. And here they just go to clean everything up. Okay. And we're supposed to, let's see, what are they sending exactly? Okay. So the reply is just yo. Okay. All right. Let's look at the content and see what we're going to learn about runtime. Okay. So far, we've been talking about async runtimes as an abstract concept. Okay. Let's dig a bit deeper into the way they are implemented. Okay. Flavors. So here we go. Tokyo ships with 2 different runtime flavors. Cool. This is what I was thinking. You can configure your runtime via Tokyo Runtime Builder. So Builder new multi-thread gives you multi-threaded Tokyo runtime. Builder new concurrent thread will instead rely on the current thread for execution. Okay. So to me, this sounds very familiar to like using the main actor in Swift programming. So whatever thread started the spawn, that code will still run on that same thread, just it will be executed later. Okay, I think that's what that means. But this time it's like an actual configuration. All right, so Tokyo main returns a multi-threaded runtime by default, while Tokyo test uses a concurrent thread runtime out of the box. Oh, okay, okay. Yeah, this is probably due to like just getting the correct values out of your testing. And you don't want, I guess, different tests to interfere with each other. So current thread runtime. The current thread runtime, as the name implies, relies exclusively on the OS thread it was launched on to schedule and execute tasks. Okay, so if my application was launched on a background thread, that would be my current thread runtime. It's on a background thread or on a background task. Okay, when using the current thread runtime, your concurrency but not parallel. You have concurrency but not parallelism. Oh, okay. So asynchronous tasks will be interleaved. Yes. They will always be at most one task running at any given time. Okay. Cool. Multi-threaded runtime. When using the multi-threaded runtime, instead there can be up to n tasks running in parallel. Okay. At any given time, where n is the number of threads used by the runtime. By default, n matches the number of available CPU cores. Okay. There's more. Tokio performs work stealing. Okay. Work stealing. If a thread is idle, it won't wait around. It'll try to find a new task that's ready for execution, either from a global queue or by stealing it from the local queue of another thread. Okay. Work stealing can have significant performance benefits, especially on tail latencies. Whether your application is dealing with workloads that are not perfectly balanced across threads. Okay. Implications. Tokio Spawn is flavor agnostic. It'll work no matter if you're running on the multi-threaded or concurrent threaded runtime. Okay, makes sense. Use the same API for either one. The downside is that the signature assumes the worst case, i.e. multi-threaded. Okay, and is constrained accordingly. Okay, so it's considering the worst of the two cases, multi-threaded. All right, so let's ignore the future trait for now to focus on the rest. Spawn is asking all its inputs to be send and static lifetimes. Okay, cool. So let's see. The constraint follows the same rationale for the static lifetime. Constraint on spawn thread. Okay, so the spawn task will outlive the context it was spawned for. Therefore, it shouldn't depend on any local data that may be deallocated after the spawning context is destroyed. Here's their example. 1, 2, and 3 in a vector. This won't, since borrowing a V will live long enough. Okay. Okay, send on the other hand, I was going to say this, so this will not work because this will happen in the background. Could happen for a long time or a short amount of time, we don't know. But we assume the worst case, which is a very long time. And then V will actually be dropped almost immediately after the call to spawn. So this doesn't work. But if you move it into there, then I bet it would work because now you're moving ownership from here into this block of code here. That's what I'm guessing you could do. Okay, so send, on the other hand, is a direct consequence of Tokio's work stealing strategy. A task that has spawned a thread, thread A, may end up being moved to thread B if that's idle, thus requiring a send bounce since we're crossing thread boundaries. Okay, so this won't work either because RC isn't send. Yeah, so you're passing in this, and then you try and move it into this spawn thread. So RC is not send, so that it cannot do that. Cannot reference count that. Okay, I don't know how this is going to help us with this exercise, but we might have to look at the solution again. I'm pretty sure we're meant to go look up and read more documentation on Tokio. That is what I'm thinking here. Because I have a first and second, and then I need the reply to display string representation. Okay, so let's see. It should accept 2 listener instances, accept connections on both of them concurrently, and always reply to clients by sending the reply. Okay, so I think what that's saying is very similar to what I did last time. I'm going to do 2 spawns. So Tokio spawn. Okay, and then I'll just do to do. And then we have So I guess what we would do is this would be handle 1 again, and then handle 2, and this is a to do for now. And then we would do the join like we did before. Outcome 1, outcome 2, Tokyo, join macro, handle 1 and 2, outcome 1, outcome 2, and if those are good, then you're okay. I think that's what that's trying to say. I said 4, but it should be let's. There we go. Okay, now it doesn't know what we're doing here, so I think that's why we have some issues. So we're going to do async move, and this is where we do our loop again. So we'll write the loop once, we'll copy and paste it. Let's see, we have our something here, our move stream, and our socket from the first dot accept await, and then we break it up into a reader writer. So then we have our mute reader, mute writer, and we have a stream dot split. Yeah. Stream dot split. Yep. Okay. There we go. And then we do, I guess, Tokyo. Would it be? It wouldn't be copy this time, right? Maybe it is. Copy. We do the. Well, we would do the reader and writer from before with the echo server, but now we're writing the reply. Whoop. Reply. But we need the format of the reply. So would that be like, I don't know, format reply. Maybe something like this. Yeah, I'm not sure about this part, the copy part. Got a lot of squiggles. I think this part, well, most of this is what we want for here. Okay. Okay. So let's do this part, async move, and then get this. But not for first, we go for second. Okay. But yeah, I don't know what to do for this copy part. Oh, my head is covering my code. Thank you. Didn't mean to do that. Let's see. Scene transition. There we go. Thank you. Thanks, guys. All right, so okay, so this is what we're doing. We have here. I'll do a couple of undos here, so you can see what I was building out before. So I was trying to build out what we had in the previous exercise. So you have 2 spawn threads. We're going to join them, and it's going to be okay. That's the idea. But now I need to take the reply, and instead of this copy for, because we were doing an echo server before, instead of this copy, I think what I need to do now is send the reply to the reader or to the writer. Or is it writer dot something? Yeah, dot something. It says writable into flush write. Could we write something here? I don't know what we would write. Can we write the reply? Yeah, so this is not going to work. Okay. Like this. Oh, but then I said maybe it's a format. There we go. And then we reply here. Whoop. Reply. And then take this out. Yeah, I'm not sure that that's what that would work with. So what does write do? Write's a buffer. U8, okay. U8. Could we make this a U8 as bytes? Okay, we're getting somewhere. So what would it be? Like reader dot read? Okay, yeah, I don't know if that works down here. We still have a lot of squiggles. Probably because we have to, do we have to await this? No, we have to unwrap it. Nope. Okay, got rid of some of our squiggles. I don't know that this would work. It might work, but if we could figure out this last part here, I don't see a return type, so maybe we don't return anything like that. All right, what do we have here? Oh, I see. So we have the reply here and the reply here. Clone. Oh, but we don't know that it can be cloned. This is where I think we need to say that the lifetime, we need to do something with the lifetimes. Use of a moved value reply. Yeah. Because all we know is that it's display. And we're moving it into this closure. I'll highlight it here. And then we're trying to use it again down here. Feels like a not Tokyo thing to figure out. Because it's display, it is send and sync, but it is a static lifetime. But we don't know what it is. Okay. Yeah, I'm not really sure how to fix that. Is there any code actions we can do? Okay, the code action was extract into variable, and that did not help us. Nice try, but it did not help us. All right, so if we could figure this out, we might have it. We might have to go to the solution for this one. Let's go to the solution. Okay, so we are in futures, and then we're in runtime. Yeah, so I know that this was imported, so this makes me feel like we're supposed to use something from here. Okay, here's our loop. Writer, write all. Format reply as bytes. So we're close. We just didn't write all. Okay. Let's go back here. Write all and all. But they did something else here. They said await this. Okay. Await unwrap. Await unwrap. I suppose they're doing that because they wanted to finish writing all the bytes. But what did they do about... Oh, I see. So they're using some of the stuff we learned in threads with arc. So they passed it in as arc. So what they did is they wrapped the reply in arc. So that's an atomic reference count. So only one can read the value at a time. So arc new reply. Okay, and then by dereferencing, that's how you get this here. But we need to import this from the standard library. I say import, but it's a use. Okay, and we don't need the reader, I suppose. So I'll underscore that there. There we go. All right, so we have the reply. It's now used in both, it looks like. Oh, clone. Now we can clone. Yeah. Okay. So now that we have reply here, we can reply with an arc clone of reply, like so. And there we go. And I think the same thing here. So clone of reply. Oop, we're getting closer. So, oh, one of them's just reply and one of them's the clone of reply. So I'll take this out. Reply. But then when they're using it, yeah, it's just reply here. Because it's an arc that can be displayed. So the value wrapped in arc can be displayed. That seems to be fine. Reader not used. Listener accept, yeah. Okay. So maybe I need to do something a little different. Okay. Because I haven't broken it out into a separate function, because then they would move into those functions, so the reply and the clone would move in. So I'll say reply clone, arc clone it, and reply, okay. And then we'll say reply clone. I think that works. Yes, it does. Works. Okay. So looks like it's a matter of, I don't know, semantics. Very different. Okay, so like, yeah, if we split it out into here, we would still be at the top level here. We could make this a temporary variable as well and then pass it in, this maybe looks a little cleaner. That's why they probably split it out into a separate function so that it looks a little cleaner up there. But then also, you can just reuse this function for something else because it's the same code I have written twice here. Yeah. Oh, okay. So there is some weird stuff down here at the bottom. I'm not sure what they do there. Okay, so here they just join the handles and that's it. So, okay. I mean, I guess that makes sense. Like so. Still have warnings and whatnot. What does this warning say? Unused results. Yeah, okay. We do that. Whoop. That works. Other warnings? Nope, no other warnings. Okay. Let's run the test, see if this works. Cargo test. Okay, cool. All right, that worked. Nice. All right, let's move on to the next thing. We have here future. All right, let's look at future. All right, so get the code to compile by reordering the statements in the example function, okay? You're not allowed to change the spawner function nor what each line does in example. You can wrap existing statements in blocks if needed. All right, so get the code to compile by reordering the statements in the example function. Okay, so they're saying get this to run by reordered. So what is the error? Let's look at that first. Future cannot be sent between threads safely. Okay. Because RC. But we can't change that part of the code, right? So we have to keep that there. So I'm supposing it's because we're setting up this value and then we're suspending and then trying to use the value after that. But these values are not what is it, sync or send? So they're not send. Future is not send as this value is used to cross and await. Yeah. So I think that means like if we did this, it would work. No. Okay, so maybe we did this and this. I think that's what that means. So it's guaranteed to drop scope here. We don't use that value anyway, so we're good. I don't know. That's I guess what I think. And I only got that from the hint of like using blocks if needed. Let's look at the solution and then let's read up what it is they want us to learn here. Okay, so futures, runtime, future. Okay, so that's what they did too. I see yield now. Okay, so suspend. Let us look at the content actually on the website. Let's see here. For future traits. All right. So the local RC problem. Let's go back to Tokyo spawn signature. Yeah. Send and send. Yep. what does it actually mean for f to be send? So for f, whatever you're putting in here needs to be sendable. Okay, it implies, as we saw in the previous section, that whatever value is it captures from spawning environment has to be send. Okay, from the spawning environment. Yeah, okay, it has to be send. But it goes further than that. Any value that is held across an await point must be sent. Yes, okay, so I was thinking that too. So this value is held across an await point. So they're saying that this value then need to be send, but RC is not send. So what do you do? And that's where we did this. So we ensure that it drops before the first await, before the first suspension. Okay. So yeah, RC wouldn't work like this. You have an issue. That's what we looked at. Okay, so I suppose we were looking at the issues in the editor, but if we looked them up on the command line, it might have been a little bit more helpful. All right, the future trait. We stated earlier that the async function returns futures type that implement the future trait. You can think of a future as a state machine. It's one in two states, either pending or ready. So the computation is not finished yet when it's pending, and it's ready when the computation has finished, and here's the output. Okay, so future, we keep polling. And yeah, so poll. Okay, so poll method is the heart of the future trait. A future is a future on its own doesn't do anything. It needs to be polled to make progress. When you call poll, you're asking the future to do some work. Poll tries to make progress and then returns one of the following, either pending or ready. And when it's ready, it has a value. So the pending, the future is not ready yet. You need to call poll again later. So keep going. You're in progress. The future is finished when it's ready, and the value is a result of the computation of the type self-output. Okay, so once poll returns poll ready, it should not be polled again. The future has completed and there's nothing left to do. Okay, role of the runtime. You'll rarely, if ever, be calling poll directly. Yep, that's what I would think. That's the job of the async runtime. It has all the required information, the context in the poll signature. Okay, to ensure that the futures are making progress wherever they can. So what about this async function and futures? So our problem that we have. We've worked with the high-level interface asynchronous functions. We've now looked at low-level primitives, the future trait. How are they related? So every time you mark a function as asynchronous, async, that function will return a future. Yes, so the compiler will transform the body of that asynchronous function into a state machine, one state for each await point. Going back to our RC example. So yeah, here's the example. The compiler would transform it into an enum that looks something like this. Not started, yield now, okay, and terminated. So I guess it collected this value. Said it would yield now because that's the await at the yield now line. So something like that. That's the idea. When example is called, it returns example future not started. So immediately returns future not started. The future has never been polled yet, so nothing has happened. But when it goes to start it, then it will return the ready, right? So then the next time, the first time, it will advance on the next await. So when await is called again, it'll stop at the future yield now portion stage and returning poll pending. Okay, so this is this next state that we're at, and it would be pending. When it polls again, it'll execute the remaining code. All right, so next time we poll it, it'll execute this thing here. and return poll ready. Okay. With no return, because we have no return type here. Okay, so when you look at the state machine representation example feature, it is clear why example is not send. It holds an RC, therefore cannot be sent. Yeah, so RC is not send. All right, yield points. As you've just seen with the example, every await point creates a new intermediate state in the life cycle of the future. And that's why await points are also known as yield points. Your future yields control back to the runtime that is polling it, allowing the runtime to pause it and, if necessary, schedule another task for execution, thus making progress on multiple fronts concurrently. Yeah, so we'll come back to the importance of yielding in a later section. Okay, so that's good to know. It kind of broke down how this state machine works. So we just changed the state machine to like run block, clean it, which also cleans up the memory, and then yield now, and then terminate. That's what we did. So a yield now with no values, no other values. So we clean that up. All right, I think that makes sense. Okay, let's go out of here. Oh, actually, there was no test to run. It was just double check cargo build. Yeah. Just a couple of warnings, but we're all good. Okay. So, okay. Let's see. So we have blocking, async, aware primitives, and cancellation. Let's take a look at blocking. Oh yeah, quite a bit to do. Okay. Let's do this. All right, we're going to stop there for today. So thanks for watching. If you guys have any questions, you can put them in the comment. This video will be posted later for you to rewatch if you'd like. Otherwise, yeah, thanks for watching today. This was the dev method. We were doing 100 exercises in Rust. This was part 13, I believe. And we'll be doing more soon, so stay tuned. So subscribe if you want to see when I go live again or when I post other videos. I have other Rust content if you want to see that. I have a lot of different videos that are based off of the Rust programming book. So if you need that as a helper, please go ahead and do so. But yeah, thanks for joining today. Have a good one, guys.